So good morning, everyone. So we'll get started with today's topic. And today's topic, as you can see on the screen, is LC oscillation. What does L stand for? L stand for inductor, C stands for capacitor. So what happens in a circuit only if inductor and capacitor are connected? What would happen? So this topic is related to a circuit which has only capacitor and inductor, and that's what we need to understand. And in case of LC oscillation, as the word suggests here, this is oscillation. The oscillation motion, one of the oscillation motion, a subset of oscillation means a special kind of oscillation is SHM. And SHM, we have come across variety of SHM motion. And one of the common SHM operation is a block connected to spring. So suppose we have spring placed on a smooth surface and a block of mass M is connected. And if it is placed on a smooth surface, if you give small displacement, it undergoes SHM motion. And this motion is something easier to understand. If I take this x as equal to mean position, and suppose I stretch it to this one, I stretch it up to x is equal to a. To stretch it to a particular distance from the mean position, more I stretch, greater is the amount of energy which I need to spend, or other way of saying is greater is the amount of energy which is being given to this spring block system. And when you release it, it will undergo a SHM operation. And there are certain things which are important when you say x is equal to a. There are certain displacements are more relevant here. What are those displacements which are perhaps more relevant? Are something like a by 2, half the amplitude, a by root 2, and root 3a by 2. We know those things are, and those correspond to particular phase angle and all. So why are we talking about SHM motion? What is happening in case of LC oscillation? It has similarities analogous to spring mass system. And spring mass system is which we can see, which you can basically intuitively we can understand better. We can visualize, we can see it. Whereas LC oscillation is a charge which is oscillating, which cannot be seen. So this is something when two things are similar, we draw an analogy with the system which is easier to understand. So this is something we'll quickly run through spring mass system. So we have spring mass system, and suppose let's take a point when it is given a displacement A. When this object is mass M is passing through point A by 2. When it is passing through A by 2, there are two directions possible. One case when it's passing through A by 2, its velocity could be towards the center. Other cases, this whole oscillation, if you start from mean position, start observation. What is this whole oscillation? It will go towards like this. Like this. This is something I think all of you recall. This is kind of oscillation. It will keep going again and again. So it is passing through particular point. Once it is going towards right, and one is going towards the left. So there are two possible directions of motion. Both cases speed will be same, but directions will be opposite. And both cases, see, when it is passing through A by 2, it has particular velocity, speed value will be constant. And even when you look at the rate at which speed is changing, this value will be, this also will be proportional to minus of x, is it not? This is something, this is the rate of change of velocity or acceleration is proportional to minus x. So when it is moving towards right, it will slow down. And the same point, when it is moving towards left, it will speed up. Because acceleration is acting towards mean position. So these are some of the common properties of SHM motion. And if we recall those properties, it becomes easier to understand even LC oscillation. So if we recall, this is something, if we plot the position with time, and this is the shape it takes, and that's why I call this a sinusoidal motion. And maximum displacement from mean position, we call this as amplitude. That is value of A. And per time also, this is something, this is a one full oscillation, and this is called, this is start from 0. This is time period T, and accordingly this becomes equal to T by 4. And what are these values here? This correspond to phase angle of 30 degree, 45 degree, and 60 degree. So 35 degree, what time it will happen? So this T will be equal to T by 12, and this will be equal to T by 8, and this will be equal to T by 6, and this is T by 4. And you will have corresponding energy also. So at this particular point, it will have certain energy here. And we know in case of a spring block system, two forms of energy are constantly interchanging, so that sum of them is constant. What are two forms of energy? Two forms of energy are potential energy and kinetic energy. and those two, sum of these two is constant, and those energies at certain specific positions, they had particular relationship. So if we take, these are the phase angles, this is a corresponding position, and potential energy is equal to 1 by 2 kx square. So when it is at the mean position, potential energy is 0. Since the sum of these two has to be equal to total energy, so when potential energy is 0, total energy, kinetic energy becomes the total energy. That's another way to define the energy of an oscillation. If two forms of energy is there, so when one form is energy is equal to 0, other form of energy is equal to total energy. And similarly, when this position is at a by 2, so if total energy is corresponding to 1 by 2 Ka square is equal to total energy. So here the displacement is half, hence total energy, potential energy becomes 1/4 of the maximum potential energy. And since this is T by 4, this becomes 3T by 4. At A by root 2, half is potential energy, half is kinetic energy, both are equal. So here what we notice, 0, 100% kinetic energy. Here 1/4 potential energy, 3/4 kinetic energy, 50%, 50%. This is 3/4 and 1/4, and this is 100% is 0. So this is how energy transfer takes place in case of SHM motion, and these are the key elements of SHM motion. Okay, now we may come to how do we set up LC oscillation. So let's see, this is the circuit here. Let's try and understand what is circuit. Switch SB is connected. How is the switch connected? Switch is connected like this. If we connect for a long period of time, this will be charging of a capacitor. So over a period of time, if we leave for a long enough time, capacitor will get fully charged. And in that case, after some time, the current will drop to 0. No current will flow in the circuit. It will behave like an open circuit. And this will have a charge equal to EC. Is it not? That's the charge it will have. So this is something, it is fully charged. So this is this part of circuit we are familiar with. We could have written the equation also. Capacitor gets fully charged at a CE. Suddenly, if we shift the switch from B to A, what will happen? We shift the switch from B to A. Now, moment I shift from B to A, what is happening? Now this circuit will comprise of only two elements, a charged capacitor and initially completely uncharged inductor. So this is how the circuit will form. This is called LC circuit. And let's try to understand what will happen moment we switch. So moment we switch, this circuit is gone out of the picture. What circuit we are concerned with? This is the initial state. This is what state is at t is equal to 0. So what we notice here, see this capacitor, now moment we make this connection here, there's a loop. See, you understand this part. What is inductor? Inductor also is a conducting wire which has been bent in form of a solenoid. We make this coil so that value of L is significant, but it is still a wire. Okay, so let's try and understand what will happen in this case. See, this is something, had it not been an inductor, what would happen if there was a resistance here? That part we know already. If there's resistance, what will happen? Moment we make this connection, this connection provides a path for charge to flow from higher potential to lower potential. So what will happen? The charge on this will diminish, charge transfer will take place. It will lead to current. That's what we have seen in case of resistance circuit. Okay, in case of resistance, that what happens? In case of when resistors were there, the decreasing rate of transfer, the current will gradually keep on diminishing. Why the current will keep on diminishing? First of all, why the charge will flow? Charge will flow from higher potential to lower potential. Okay, but as the charge keeps decreasing, potential difference keeps dropping. Hence, IR also keeps dropping or current keeps dropping. So basically, that's how we can define. If there was resistance, decreasing rate of transfer of current with loss of energy. But when there's resistance, it will also lead loss of energy. So what is happening here? The potential difference across the capacitor at any instance was equal to instantaneous value of current into R. That's how we form RC circuit. Something similar also will happen here. So moment here, see, if there was no inductor, no resistance, immediately the whole charge would have been transferred. But because of inductor, as the charge transfer takes place, suddenly, but when charge transfer starts, it means current will increase. If the current tends to increase, it will oppose the increase in current. And inductor always, this is something inductor start acting as a battery when the current changes. So this is something, since the current is, I hope all of you clear, initially the current was 0. As soon as you make the connection, the current will start. Current will start with current will tend to increase. Which direction? This is a direction with the current will tend to increase. This is a direction charge will flow. And since the current is trying to increase, it will oppose the increase, that with the polarity of induced EMF. Okay. So L will oppose instantaneous transfer of charge. If L was 0, and the resistance was 0, in charge would have got transferred practically in 0 time. It will oppose. So what is potential difference across? What will happen in this case also? So if you look at how do we understand the potential difference across capacitor, just basic application of Kirchhoff loop rule. In magnitude, this also will be equal to potential difference across. It will be equal to induced EMF here. We are assuming the resistance is 0 here. There's no resistance. So potential difference here is equal to induced EMF. So potential difference across capacitor at any instance will be equal to induced EMF, which is equal to L di by dt. So what is happening here in this case? What will happen? Q0. Q0 will remain constant, will keep on decreasing. The charge on the capacitor, as the current start flowing, charge will keep on decreasing. As the charge keep decreasing, it means potential difference also will keep on decreasing. But potential difference polarity will remain same. The potential difference, this will remain positive and this will remain negative. So as charge decreases from where? Charge will decrease. Let's say we are talking about decrease of charge from Q0 to 0. So during this state, everywhere at all instances, this side is positive and this is negative. So polarity is not changing. So potential difference across capacitor will remain positive but will keep dropping. If it remains positive, it means di by dt also will remain positive. So during the period, the charge is reducing from Q0 to 0. Di by dt, rate at which the current will grow, will remain positive but it will keep on diminishing. So how do we state in form of words what will happen during this stage? Current will keep increasing till the charge on the left is positive, though at a decreasing rate. I hope you understand why di by dt will keep decreasing, because potential difference across capacitor is decreasing because charge is decreasing. So the current will keep increasing at a decreasing rate. So when the current is 0, so okay, and gradually when it comes to state when the charge becomes 0. When the charge becomes 0, what will happen? When the charge is 0, potential difference across capacitor is 0. It means L di by dt is equal to 0. So di by dt is equal to 0 means what? What is the condition di by dt 0 means? Current is maximum. So when charge becomes 0, current will stop increasing. Di by dt 0, current is maximum. Thus the time the current will become maximum. And we see it is somewhat similar to what happens in case of mass spring system. Okay, what will happen afterwards? So during this stage, what has happened? So let's see what will happen thereafter. So now it has reached a yes, Vignesh.
So I didn't understand the part about why the current will increase.
Okay, why would current increase? Have you understood this part here?
Yes, sir. In terms of the equation, I understood.
Initial current was 0?
Yes, sir.
Okay, so moment current becomes non-zero. What does it mean? Has it increased or not?
Yes, sir.
Okay, so basically in this one moment you say current gets established in the circuit, it means current has increased from 0 value. Okay, and second thing, is this clear? Have you understood what does this equation imply? Where does this come from? PT will come to equation also. A potential difference across capacitor has to be induced EMF. Okay, so in this case, as long as this is positive, okay, so if I rub a loop, if this is positive, this has to be polarity. And potential difference across capacitor is equal to L di by dt. So as long as potential difference across capacitor has a particular sign, di by dt also will have the same sign or not? As long as charge on this remains positive, so from Q0 to 0, throughout this process, this charge has remained positive. So which plate has high potential? The left plate is at high potential. So as long as this has a particular sign, di by dt also will have same sign. Yes or no?
Yes, sir.
If di by dt has same sign means what? But there is something. But its magnitude is this quantity. This also it has a particular positive sign. Okay. From where? From Q0 to 0. But is this value constant or decreasing?
Decreasing.
Why it is decreasing? The potential difference is Q by C.
Yes, sir.
The charge is decreasing. It is positive but decreasing. So what will happen here? What does it imply for? So in terms of word, how do I state this relationship? That current will keep growing because it is positive, but at a decreasing rate. So I'm just stating this relationship in form of words. We'll come to the equation also later, but first we have time to understand what is happening. So current will grow at a decreasing rate. So rate of growth initially higher, but rate at which current will keep growing, will keep decreasing, and finally it has reached a maximum. Di by dt. Does it make sense that di by dt will become 0 when charge on the capacitor is 0? When the charge from Q naught, it becomes, when charge becomes 0, so potential difference across capacitor becomes 0. So induced EMF, this also is 0. It means L di by dt is 0. So di by dt is equal to 0. What does di by dt 0 imply? Rate of change of current is 0. And any quantity, when dy by dx is equal to 0, it means y has become maximum with respect to x, which means current has become maximum. So when does the current become maximum? The current becomes maximum when this charge has become 0. What will happen? So thereafter, no, but this charge has become 0, but now there's already current. Can current suddenly drop to 0? No, current cannot suddenly drop to 0. Inductor doesn't allow sudden change in current. So at this particular stage, what I know, I have come to a stage where the charge has become 0, but the current is flowing in this direction. So will the charge remain 0 if the current is flowing in this direction? It is equivalent to transferring the charge from this plate to this plate. What will happen after the charge has dropped to 0? The charge has dropped to 0 from Q naught to it has become 0, and the current is equal to I max. Current is flowing. What will happen thereafter? Since the current continues, since the current is going like this, it means charge is getting transferred. From 0, if the current continues, it means positive charge is getting deposited on the right plate. So as long as current is flowing in this sense, it means positive charge is reaching the right hand side of the capacitor plate. So what will happen soon after reaching 0? So it was something like this. It was Q naught here, and it was minus Q naught. After some time, it has become some value of Q. This has become minus Q. It is Q is lower than Q naught. Then this has become 0 and this has become 0. Afterwards, further transfer. So what is happening? I am adding positive charge here. So what will happen now? This will become negative and this will become positive. So what will happen thereafter? Right plate will start acquiring positive charge. Okay. So during this process, Q naught to Q, what has happened? As the charge on the capacitor has dropped from Q naught to 0. In terms of energy, what you can understand, as the charge on the capacitor is decreasing, energy stored in the capacitor is decreasing. And where is this energy going? See, both capacitor and inductor, as the charge changes or current changes, there's no loss of energy. So what is happening during this process here? During the process, charge has dropped from Q naught to 0 on plate. Energy in capacitor has decreased, and there's a corresponding increase in energy stored in the inductor. So during this stage, there's a transfer of energy from capacitor to inductor. Okay, so can we drop in terms of understanding what has happened here? See, this how the charge was initially. What I know, I'm drawing for which stage. Let's draw how the charge will change with time, and how would current change with time. Up to which state? From Q naught to 0. So let's say at time t naught t is equal to 0. What are the charge here on the capacitor? On the left plate, charge was Q naught. At certain value of t, this charge has become 0. So these are 2 points here. And corresponding, what has happened to current here? The current here was 0 at time t is equal to 0, and current has reached a maximum value at which time? It has reached a maximum value time. And reached maximum is here the slope has to be 0. Here the slope has to be 0. And what he is saying here, if slope is gradually decreasing, di by dt is gradually decreasing, that's the shape of current. This is something without doing mathematical equation. If I understand sequentially what is happening, this is how the current should have changed. What I notice here, current has grown from 0 to maximum value. During the period, the charge on the capacitor has dropped from Q naught to 0, and rate of growth of current has slowed down. So di by dt, slope is positive, but magnitude of slope is decreasing. This is what happened to current. Can we draw what will happen to charge? See, once I have current, I can draw the charge. What is charge equal to? See, when I, at any instance, dq by dt, slope of qt curve has to be equal to I. Slope of qt curve, the magnitude of slope has to be equal to I. So basically here I is 0, it means slope here dq by dt has to be 0. And here as I keeps increasing, the magnitude of slope also has to keep on increasing. So this is something here starting in 0 slope and reaching maximum slope. That would be the shape of, this is something again, this is the shape of qt curve. This is how charge will vary with time. This is something based on qualitative discussion. If some of you can follow, we have only made use of one term. What is the term we had used of? At any instance, potential difference across capacitor is equal to L di by dt, or at any instance Q by C is equal to L di by dt. That's the only thing we have made use of. Based on that equation, if I understand a Q is dropping from Q0 to 0, and based on this equation, I can more or less understand this will how charge and current will vary with time as the charge drop from 0. What we continue further, soon after charge the capacitor is 0, current is maximum. That's a stage. Now current has reached its maximum. It means current has to start decreasing now. It is means maximum is now the current has to decrease. If current has to decrease, what has to be polarity of induced EMF? Now it starts supporting the current. So whenever current increases, it opposes the current. Now current is decreasing, it will support the current. That will become the polarity after this. And since the current is reaching here, the current is transferring more and more charge here. Charge on this plate will keep on increasing thereafter. So which state we are talking now? We have, so from Q0, it has dropped to 0. Now we are talking afterwards. Afterwards, now this will become negative and this side plate will start acquiring positive charge. So other plate of it will start getting positively charged. Charge on the positive, this capacitor, charge will keep increasing. And as it keeps increasing, induced EMF also will keep increasing. Sorry, EMF across capacitor will keep increasing. Sorry, potential difference will keep increasing. Hence, this EMF also will keep increasing. If EMFs keep increasing means what? Di by dt also, current will keep growing, rate of decrease will keep decreasing. And during this phase, what is happening? Now, current will decrease means energy in inductor is decreasing, and charge on capacitor is increasing means energy stored in the capacitor is increasing. So this phase now energy is getting transferred from inductor to capacitor. So as the current now slowly, as the current decreases, anything which keeps decreasing finally will come to 0. So now in this case, during this phase, what has happened? Charge on this plate, if I look at charge on this plate has become 0 to plus Q0, and accordingly charge on this plate becomes 0 to minus Q0. And that when it reaches maximum. When it reaches maximum value, we know from conservation of energy, that time the current will become 0. So the current gradually decreases to 0. Charge will increase to maximum value of Q0. It will not go beyond Q0. Why it will not go beyond? Because Q more than Q0, because the energy in the whole system cannot exceed the, say, energy remains constant. So when okay, so this total energy in this system will come to that again. So it will reach a maximum of Q0. And okay, now let's look at more mathematical terms. That is something what we have seen in terms of Kirchhoff loop rule. Same thing, equation what we have written. So in this case, if you have to write equation, let's start from here. How would I write the equation if I move along like this path? If I like Kirchhoff loop rule, which case I have taken? I have taken the charge Q is decreasing, and this is the direction the current is flowing. If current is flowing in this direction, it means this charge is decreasing. So if I take this at a particular instance, we are writing this Kirchhoff loop rule at some random time t. So from here, negative to positive plate is Q by C. And here this is the polarity. If the current is increasing, it will oppose the current. So here, induced EMF, we are moving from positive plate to negative plate. Hence, minus L by d by dt is equal to 0. Second thing what we need to know, this current I and Q are related. This current is coming from where? Because this is something, the current, this charge is getting transferred from this plate to the other plate. So in this case, charge is getting reduced. Rate of reduction of this charge is nothing but current. So if I write what is I equal to rate of reduction of charge, which is minus dq by dt. So when we take this kind of convention, current has to be equal to minus dq by dt. Other way to understand, as the time increases, charge is decreasing. So we have seen whenever you write this equation, if they two are in the opposite direction, the sign becomes negative. So this equation now becomes very simple. So we can, in place of I can write dq by dt. So if I write in place of I dq by dt, this term, this equation becomes like this. This term becomes positive, we take it to other side. Why we written like this? This equation what we write, we find this equation is similar to a spring mass system. In the spring mass system also, if we write Fx is equal to ma. Yeah. So what is, in case of a spring system, m into d square by dt square, this mass into acceleration is equal to force when this is equal to minus kx, which is, and we compare these two equations. These two equations are similar. If I know the solution of this equation, I can easily interpret solution of this equation. What is solution of this equation here? As such an equation. What value of x as a function of time will satisfy this equation? That we know already. In case of SHM, equation we satisfy x is equal to x naught sine of omega t plus phi. And how do we get value of omega? We'll come to that also. So if that is the case, in place of x, we have q term here. So the q also will equal to q naught sine of omega t plus phi. Let's understand here this equation can also be written as d square to dt square, d2q by dt square is equal to minus L by CQ. And this equation can also be written acceleration is equal to minus omega square x. So if we compare what is the value of omega here, so this term charge also will oscillate. So if I take how the charge will vary with time, charge on the capacitor will vary as a sine function of time. And it varies a sine function. This also, it will be a periodic kind of change of charge. And the time period or omega can be calculated from here. If I compare those two, what has the value of omega here? In this case, omega is used to what is omega in case of SHM motion, spring mass system, root k by m. Here omega will be, if I compare those two equations, omega square is equal to L by C, or omega is equal to root by C. So this chapter, this particular topic, these are only two things which are important. And if we understand how to make use of these two things and relate to SHM motion, everything can be solved. So there are only two things. Charge will vary as a sine function of time, and omega will be equal to 1 by root LC. And as the charge will vary, accordingly energy also will vary. We can write all those two terms. Once we Q, can we find out current as a function of time? Will the current also will vary? Yes, current also will vary. How would current vary? Can we write current as a function of time? Once I have charge as a function of time, charge will vary as a sine function. Can we think of how would current vary? Current is nothing but dq by dt. If I differentiate, I get the current equation also. Okay. And what was the total energy here? Total energy also, the way we write total energy is equal to kinetic energy. There are two forms of energy. So we can write when charge is maximum, that time current is minimum. I can write as Qm square by 2c. This indicates the maximum charge. When the charge on capacitor is maximum, the current is zero. Okay, because dq by dt is zero, that's maximum charge. And when the current in inductor is maximum, charge is zero. So that's the total energy, or any particular intermediate state at particular time if charge is q. The total energy is equal to energy stored in the capacitor plus energy stored in the inductor. So this is q and I at a particular instance of time. So any of these three forms similar to what we write in case of SHM motion. That's how energy is. So these are three things we'll make use of. Okay. What you're saying, this is how charge will vary as a time. The charge is a sine function. This is how the charge will vary. If this is how the charge is going to vary, and this is t. So for a particular circuit, if I know the value of inductor and capacitance, can I find the value of t? How much time does it take to complete one full cycle? Once I have the value of omega, I can find t also. It's pretty easy. T will be equal to 2 pi by omega. And this is how the charge will vary. And once we know how the charge will vary, we can draw the I graph also. How would current vary? If I have this curve, this is how it is varying as a sine function. Can I draw the current time graph? From this, can we draw the current time graph? What will current be? Current is dq by dt. So at any instance, slope of this curve will indicate instantaneous value of current. Which point is the slope maximum? At this point, sine function. At this point, slope is maximum. At this point, slope is zero. So what does this imply? Here the current will be maximum. Here the current will drop to zero. So similarly, so this, if we repeat the same cycle, I can get this is the shape of current graph. This is how the current will vary. Okay. So whenever charge is zero, current is maximum. When the charge becomes maximum, current drops to zero, and in between they vary as a sine function. This is how the current would be. And so from this equation, at any instance of time, once I have, and what does phi depend on? Phi depends on based on when do we begin our observation. This phase constant depends on choice of time t is equal to 0. If we take this kind of shape, so if we start my observation, when the charge on a capacitor, one particular plate of capacitor was 0 and charge was increasing, if I take the time is equal to 0, the phase constant for charge function becomes 0. Okay. And this is something how we relate to. Okay. So what is this? This is something what you can find in your NCERT book also. Let's see what it says here. This particular case, what does this figure indicate here? It indicate there's no current here. There's no current. There's no magnetic energy here. So this is an initial state. One plate has this as positive charge. This is a negative charge, and this is how the field is. When the charge is maximum, field is maximum, and total energy, entire energy is stored in form of energy stored in the capacitor. And okay, and this system, okay, sorry, maybe I can do this first. So when we can compare those two oscillation, if we compare, what are those two equations? L d square x by, let's go back to that equation. I think which equation I'm talking about. Okay, when your derivation, we came across the equation. Okay, this equation. So if I look at this equation, what is equivalent to mass here? Equivalent analogous to mass is L. What does mass do? Mass opposes sudden change in velocity. What does L do? L opposes change in current. So what we have velocity here, equivalent to velocity is current. In terms of x, in place of position, we have term q. So q charge is analogous to position. L is analogous to mass, and you can think of it. But what does L do? What was M? What was being done by M there? Same thing is being done by L here. That's why inductor is also called electrical inertia. Okay. And what is K equivalent to? Inverse of capacitance is equal to spring constant. So these are the equivalent terms, and we can relate to. So sometimes yes, we can relate all these terms from this equation, and okay. So in this system also, one in this case, when charge is maximum. So if I have to draw a spring block system, this case corresponds to what? Q is max. What is Q max means? Q is corresponding to position X. When Q is max, spring block system, and if we are taking this direction positive, so here also a mass should be at its amplitude. So this system is corresponding to this system of this position of the spring. In this case, entire energy is stored in form of potential energy. Okay, so this is analogous system, and then the charge start flowing. As the charge start flowing, the current starts building up. As the charge start flowing, what you notice here, the field has become lesser in magnitude, charge has become smaller, field has become less, hence energy stored in the capacitor has become smaller. But the current also started flowing in the inductor. As the current start flowing, magnetic field will develop here. This case is similar to the mass has started moving from extreme position. It has started moving towards center. It has acquired certain velocity. It has certain velocity. And what is this velocity analogous to? Velocity analogous to current here. Velocity here is increasing. Hence, what is happening to current also? Current also is increasing here. If I draw this, current is increasing, here velocity is increasing. Okay, now what is the condition here? Moment here the field has become zero. When the field has become zero here, the current has become maximum. Entire energy is stored in inductor. What is the corresponding spring mass system? The mass has come to the mean position. The velocity has become maximum. What will happen after that? After that, position will become negative. What will happen here also? The charge will become negative. The charge, more charge is still flowing from here. The charge will start depleting, will become negative, and it will. So this is similar to so negative charge here. If I am defining my system of measurement of charge, and charge on the upper plate I am taking as positive is equivalent to object being on right hand side being positive. So here this charge has become negative. Of course, the overall charge is zero. But if I take a particular sign convention to define charge on the capacitor, this has become negative. So this also position has become negative. In this case, what will happen to as it moving from here? It is moving away from the mean position. It means what is happening? Magnitude of is moving farther from the mean position. So here also, as magnitude of x is increasing, magnitude of charge also is increasing. It is becoming more and more negative. And what is happening to velocity here is decreasing. So this current also will decrease here. Then it can reach the negative extreme minus a. Negative extreme, the charge also from plus q, it has become plus q naught, it has become minus q naught. And here the energy has become zero. So this is how we can relate a spring block analogy. Okay, and this is the okay, those terms. What your velocity is equivalent to, see, mass is analogous to L, force constant K is equivalent to 1 by C, X is analogous to Q, and based on that, V is equal to dx by dt. It will become dq by dt current, and this is mechanical energy, or the two forms of energy. So essentially, that's what LC oscillation is. We relate it to SHM, and many question, and as I said, but there are only 2-3 things we have to make use of. If we apply it properly, and some cases we find difficulty, we can think of in terms of spring block system, and we can solve such question. Okay, let's look at some applications of the same. In case of LC oscillation, maximum charge on the capacitor is Q. What is the charge on the capacitor when the energy stored is equally between electric and magnetic field? Can we think of a way to answer this question? What is the charge on the capacitor when energy stored is equally between electric and magnetic field? And if we take this, as we seen earlier, if I take this as a Q charge, and this is I. Okay. So what way you can relate? Can you think of finding an answer? Can anyone suggest what is the way to find an answer to this question? What is the charge on capacitor when the energy stored is equally between electric and magnetic field? So in case of spring mass system also, when is kinetic energy and potential energy equal? What is the phase angle, what time, and what is the displacement?
5 by
So one
4.
way I can, okay, one way I can relate it to spring mass system. Second, Mr. I can simply solve. Well, what is the maximum charge? I can find for, so when the charge on capacity, when the energy is equal between electric and magnetic field energy, let's write. What is the total energy in this case? Can someone tell me what is the total energy of oscillation, LC oscillation? Is that information given? What is the total energy here?
Capital Q square by 2C.
Q square by 2C. The total energy is when this entire energy is stored in terms of charge energy. So total energy is equal to Q square by 2C. This is what is given here. Now, when energy is stored equal, now we have to solve if energy is stored equal. In that case, energy in capacitor will become how much? Energy in capacitor, UC plus UL is equal to total energy. When both are equal, it implies UC will be energy stored in the capacitor will be half of total energy. Then only it is equal. So let me write the charge is Q at that instance. Based on this, I can find the value of Q. So when charge is Q, energy stored is equal, we have to find the charge. Q square by 2C will be equal to 1 by 2 of total energy. So what is Q equal to? And we have seen earlier also, which position it corresponds to. Basically, the three important positions. What are three important positions in terms of charge? This corresponds to phase of 90 degree. There's a phase of 30 degree, 45 degree, and 60 degree. What is the ratio of energy here? In this case, 0 here. At this point, it will have 1/4 of the total energy. At this point, it will have half the total energy. At this point, it will have 3/4 of the energy. And this time, it will have the total energy. And we can relate. So when would it? So at what time it will happen? That also it will correspond to the phase angle of 45 degree. So that's another second question is something of that nature. Let's look at the next one. This also past question. Fully charged capacitor charge Q naught is connected to at time t is equal to 0. Okay. So what is the curve here? The time t is equal to 0. The time at which the energy stored is equal between electrical and magnetic field. Can we find an answer for this question now? At what time? So first of all, can we write a charge as a function of time? So charge is Q is equal to Q naught sine of omega t plus phi. What is, can we find value of phi phase constant here? At t is equal to 0. What is value of Q? Q is equal to Q naught. Okay. So what does this mean? What is the phase constant if Q is equal to Q naught? What has the value of phi? Q naught. So sine of, yeah, so t is equal to 0, phi has to be equal to, this implies, what has the value of phi? Phase constant has to be equal to pi by 2. So this is something like this. So Q I can written Q is equal to Q naught cos of omega t. So what is the time it will take for energy to become equal between electrical and magnetic field? How much time it will take? How do you find? What has to be value of Q when they become equal? We have already done. Can we calculate what is the time it will, at what time this energy will be equal? What has to be value of Q? Energies are equal. Q has to be equal to Q naught by root 2. So at time t, energy is equal. If at time t energy is equal, Q is equal to Q naught by root 2 is equal to Q naught cos of omega t. And what is omega here? Preetham, what is omega here? Is omega given in this case? Preetham? Is omega given here in this case? Advai, is omega given in this case? Yeah, Vignesh, you raise your hand. Some query?
Yes, sir.
Huh.
Sir, while deriving the expression, we got the phase constant as 0. The initial state we took was when the charge on the capacitor was 0, sir. While deriving this expression.
While deriving this expression, see, okay. See, in case of SHM motion also, what does phi depend on? See, if we derive this equation, okay, I have taken time t is equal to 0 here. Can someone take time t is equal to 0 elsewhere?
Depends
Yes,
on where you start the observation.
Where the observer is, we can take the time t square. Is it something oscillation is going on? So I see, say, suppose SHM is going on. So we can derive at certain time, but this is something when we look at. So that's why I write the general equation is like this. What would phi depend on? Tell me, Vignesh. What does phi depend on?
when we start measuring time.
Understand measuring time. And that is nothing but the transformation of axis. I can choose time anywhere. So in this
Yes,
case,
sir.
when is the charge taken? But this is fully charged capacitor initially connected to coil. At time t is equal to 0. So what is the charge
Yes.
at time t is equal to 0? Charge is maximum at Q naught. Okay. So can the phi value change? Yes, phi can change. Exactly same thing what happens in case of SHM motion. So can you find value of time? Is the omega given in this case? What is value of omega here?
1 by root LC.
1 by root LC. So in this case, can we find even omega can be written as this equation? Can we find value of t here? How do you find value of t? In place of omega, I can substitute value of omega. So basically, can we find value of t here?
Yes.
Let me ask some of you. Brinda, can you find value of time here? At what time will the energy stored become energy is equally shared between electric and magnetic field? Brinda? Brinda? No response? Okay. Tejas? Okay.
Yeah.
Okay. So can you calculate value of at what time will the energy be equally shared between magnetic field and electric field?
Yes, sir. Yes, sir. We can do that.
You can tell me how would you do that?
Yes, so from the equation we wrote here, I will get cos omega t is equal to 1 by root 2, right, sir?
Right.
So omega t is equal to pi by 4. And we know that omega is equal to 1 by root LC, right, sir? So we just
Yes. Easily
transpose
can
it that
solve.
way.
If
Yes.
suppose I write this equation, V value of Q. Q is equal to Q naught is equal to Q naught by 2, Q naught by root 2, and root 3 Q naught by 2, and 0. How would energy be shared between electrical energy and magnetic energy? What is the proportion? Can you tell me the proportion? Is that difficult to tell what the proportions are? At Q naught, when the charge on the capacitor is maximum charge, What proportion is electrical energy? What proportion is magnetic energy, Tejas?
Electric energy will be total energy, right, sir?
This ratio, so this will be total energy, this is 100% and this will be 0%.
0%.
When is Q naught by 2?
It will be
So I have
total
written
by
other way
4.
around. I should have written root 3 naught T naught by 2 in the same order. So in this case, what will happen here?
Be total energy by 4, sir. That's
This will be 75% and this will be, so this will be 25%.
25%.
And this will be 50-50.
50.
And so this is 1-0, this is 3:1, 1:1, and this will become, yes, this will become 25 and 75.
25.
And this, all such questions are very easy to answer. So all such questions are easy to answer. This will 50-50. So and exactly same thing we do in case of SHM motion also. Okay. Let's look at this question. Can we get yes? Yes. Any query?
Sir, in the previous, yes, sir. Why have we taken the cosine function?
Why have we taken cosine function? If I take sine function, okay, I can return as see if I use this equation. See, I think some of you need to again we have to refresh some part of SHM motion. When we write this equation here, do you understand what is this term called phi here? This is the term we use. See, if you go to SHM again, SHM has 3 important parts. What are 3 important parts we write SHM equation? I think you need to refresh a little bit of SHM equation. See, side something if I write x is equal to xm sine of omega t plus phi. Okay, and suppose I have written this equation for a spring block system. If I write for a spring
Yes, sir,
block
got
system,
it, sir.
no, omega root will be k by m. Now, what is this term called here? Then who asked this question?
Me, sir. I got it, sir, actually.
You got it, but can you now?
Yeah.
Okay, you got it also, but you have to tell me now. What is this term called? We have used certain 3 terms here. We call this this angle also we give it some name. This also is given some name. Can you tell me what is the name used for term phi here?
Phase constant, sir.
Phase constant. And what does phase constant depend on? And how do you find phase constant? What does phase constant depend on? Okay. And what does xm depend on? Suppose a spring block system. What does xm depend on? Amplitude. And what does omega depend on? And this is called whole thing. What is this called whole thing? Whole thing called a phase. And this thing is called phase constant. Phase constant is value of phase at time t is equal to 0. Phase constant depends on time, whichever time. If spring is something is oscillating, I can choose time t be 0. I can press the stopwatch at particular instance. Depending on when we start measuring the time, the phase constant will depend on that factor. So this particular question, we have taken time t is equal to 0. Our stopwatch has been pressed when the charge on the capacitor was maximum. Okay, and for that condition, this has to be equal to pi by 2, and we can solve. I think all of you need to practice. You just go through all these questions, and some more practice need to be needed in SHM kind of. So let's look at this. Can we get an answer for this as well? So inductor, there's inductor connected to a capacitor. Is set into oscillation. So in oscillation, charge will vary as sine function. Current also will vary as sine function. Q denotes instantaneous charge on the capacitor. I current. It is found the maximum value of Q is equal to 200 microcoulomb. Gayatri?
Yes, sir.
Can you tell me based on the information you have read up to this part here? This part is given. There's LC circuit. The L value is given. C value is given. And maximum value of Q is given. Can you, based on this, can you tell me what is the total energy of oscillation in this case? What is the total energy of oscillation, Gayatri? No idea? Bhagishri, what is the total energy in this particular case?
Q square by 2c.
Huh? Q square by
2c.
2c. At this time, when energy is maximum, the entire energy in form of energy stored in the capacitor. Huh? That's the total energy. Vignesh, again some query, some question?
Yes, sir.
Tell me.
Sir, if we have a fully charged inductor and the capacitor is uncharged, and if we connect it with the capacitor, even then will LC oscillation occur?
Yes. See, what is happening? Can you give me a logical reason why would that happen? Okay, even we connect capacitor, in capacitor is fully charged. Will there not come a stage when entire current is only in inductor and there's no charge in the capacitor?
Yes, sir.
Exactly same thing. So we'll come to that part also. Yes, we can set it up. I can draw a circuit the way we are connect. We interchange the position of capacitor inductor, same thing. And logically it makes sense.
Like a magnetic energy.
See, actually, yes. So basically, what see it is equivalent to saying, see, what are the how do we set spring block system in oscillation? Can you draw an analogy? A spring block system, there are two ways of setting in oscillation. Can you tell me which are the two ways of setting oscillation? I can pull it, stretch it to point of amplitude A,
Yes, sir.
and
Or
release
we can compress it.
And second thing, no, not compressing it. No, it's still not coming to the right point. Both cases, I'm giving only potential energy. What is the second way I can set into oscillation?
We
I
can
can impart velocity at this point. I can just hit this block and impart velocity. So I can set into oscillation just by giving kinetic energy. I can set into oscillation initially giving potential energy, or I can set into oscillation and bring it to some point and giving both the things together. So there is a potential energy and this kinetic energy. In that case, I have to add it. Are you following so far?
Yes, sir.
Okay, now coming to this question here. So this is something what is given here, but when maximum Q is given, so basically moment this is given, we know what is the total energy. Okay, so now if I ask some question like why some of people, I think Vrinda there's no response, and I find some other people no response. Advai also no response. Anvita, can you tell me, Anvita?
Yes, sir.
Now, can you tell me what will be the charge on the capacitor when the energy is equally shared between capacitor and inductor? What will be the charge? This is maximum charge. What will be the charge on the capacitor? At this stage, entire energy is in capacitor. So when Q is equal to 200, so I am writing Q and energy in capacitor and energy in inductor. So when Q is equal to 200, entire 100% is here and this is 0%. What has to value of Q? This is 50-50. Can you tell me, Amrita, what has to be the charge on the capacitor when energy is equally shared between capacitor and inductor?
Q0 by 2.
Q0 by 2. This will be 100 micro. And if this has to be 75%, and the energy in capacitor is 3 times the energy in inductor. In that case, what has to be charged here? Are you following this one? And
Yes.
finally, sorry, what I've written. What has to be charged here? Not Q 100. What has to be charged here?
Q0 by 2, sir.
Q0 by not 2. Q0 by
Root 2. Yeah.
And when it is Q0 by 2, actually the energy becomes 1/4. No? Q0 by 2 energy becomes 1/4. This will become 25. This will become 100. And when it is 100, 200 by 2, it becomes 25%. It becomes 75%. Let's with this part at least if you do few times, I think you'll understand. Same thing happens in case of SHM. Okay, now let's try and answer other question also. When Q is equal to 100 microcoulomb, what is the value of dy by dt? Can you think and how do you find an answer for this, Anvita? Q is given at 100. What is value of dy by dt? How do I find dy by dt? Is there any equation which relates Q to di by dt? Anita, can you tell me what is the value of dy by dt when Q is equal to 100? Not sure. Hemant? When Q is 100, so at any particular value of Q, there is a particular value of dy by dt. So as we say, if we relate it to spring mass system, when displacement becomes half, there's a particular velocity. This is equivalent to velocity, displacement is half. Hemant, can you tell me what is the answer? How do you find an answer for this? This part. Hemant? No answer. Vrinda, no answer. Hemant, no answer. Well, third person also. Advai, no answer. Okay. Kirtana, can you tell me how to find an answer for this?
So we can use that Q is equals to Q0 sine omega.
Q is equal to, but the dy by dt term is not coming in that equation. I have to have an equation which has q term and dA by dt. Where do I get that equation which has q and dA by dt term?
Sir, I is equals to dq by dt.
I can, but the differentiate again. Current
Yes,
and
sir.
any other value, any other term, any other equation which has q term and dA by dt term. Anywhere else, other equation we use? Actually, the basic derivation is based on what? Q by C is equal to. You remember this equation in terms of magnitude?
Yes, sir.
We could have done that also. Okay.
Yes, sir.
Can you answer the second part? When Q is equal to 100, what is the value of current? When Q is equal to 100, I can write Q equation. So can I write Q equation here? What is the Q equation? What is the Q as a function of time? We'll be able to Q sine of
Omega t plus 5.
what is Q? And so I can which is equal to, so when Q is equal to 200, what is the value of current here? Do we need to differentiate, or we can easily find it out what is the value of current here? When Q is equal to 200, what is the value of current? It is equivalent to saying, can you think of what is equivalent question for a spring block system? What is this Q? Q is equivalent to a spring block system. If I had to draw a spring block system, where is the particle at Q is given maximum displacement? When block is at the maximum displacement, what is the velocity? I is nothing but velocity. When the block is in maximum displacement, what is the velocity of the block? When it is a maximum displacement, this is a mean position and this is a maximum displacement. And this is a mean position. So when it is x is equal to a, is equivalent to saying q is equal to q naught. At this point, what is the velocity of the block? Not clear? Jaideep?
Yes, sir.
Can you tell me what is the value of current here?
It should be 0, sir.
Yeah, tell me 2-3 different ways why it is 0.
Because we take it in terms of the oscillation wave, so the object is at the extreme position, so the velocity should be 0.
It is, if I take a, so basically one way I can relate it to, this is similar to block being at maximum value of displacement. At maximum displacement, velocity is 0, hence current is 0. That is spring block system. One is K block M system. What is the other way can answer I0? I can write Q term and all those initial we can do them. Any other way we can find I0?
Complete energy is in the
All
form
the
of
energy is in electrical energy.
So there's no energy stored in the inductor, no second thought. So basically third part I can answer, total energy is in capacitor. Hence energy stored in inductor is 0 and hence I has to be 0. There are a number of ways. Can we find maximum value of I? And all this question is part of assignment. All of you have to finish this one today. So you think of it, I'm not writing the answer. You need to learn and solve. What is the maximum value of I? How do we calculate maximum value of current?
complete energy is in the form of magnetic energy.
Yes. So this also should be simple. I equate, when the current equate total energy to 1/2 I Lmi square. And what is when I is equal to 1/2 its maximum value? What is the value of Q? Okay, let's be quiet. Can someone answer without putting pen to paper? When I is equal to half its maximum value, what is the value of Q? What is the value of Q when I is half of the maximum value?
√3 by 2 times.
√3
Total
by 2
charge.
times. I think once we get a hang of this, very they don't have to do any calculation. When I is half, it means the energy stored in inductor is 1/4 of its maximum energy. If it is 1/4, it means 3/4 is stored in capacitor. So this is corresponding to this condition. Can others also can figure it out? What I'm saying now, is this easy to figure it out? Okay. So in this question, all of you just read through. Can we find maximum charge? How do we find maximum charge in this case? Can we find the maximum charge in this case? Karthikeya, can you find the maximum charge here? Tell me how would you find maximum charge in this case?
Yes, sir.
Okay. Can we find maximum charge in this case? Have you read through the question? The question is pretty simple here.
Sure,
Question is, can you find the maximum charge? X is initially joined to Y, and then is shifted to this is initial one. So initial one, what? In this case, energy is given to what? Energy is given to inductor. When it is initially connected, after a long time, what will the current be? This current will be equal to E by R. And when I switch from here to this point, okay, now it becomes an LC circuit. In this case, initially the total energy has been given to inductor. So now energy, this also the charge will keep changing. So can you tell me, Karthikeya, what will the maximum energy, what will the maximum charge on C? How do we find it out? No? Disha, can you tell me how to find maximum charge here?
Yes, sir. Like if we compare to the mechanical system, we see omega A, so we can substitute the corresponding values.
Or we can simply do this one also. Is it not? See, in this case, what is the total energy? Total energy is equal to 1 by 2 IL max square. And this is the maximum current. What is maximum current? I could have written total energy is equal to energy stored in the inductor when the current is maximum is also equal to energy stored in the capacitor when the charge is maximum. So I equate those two, I can find the maximum charge. Disha, is it clear? Is it not?
Yes, sir.
This basic energy equation. Okay. So these are questions which you need to do. And so I think the time is up. I'll stop here. Okay, maybe next one question also. Yeah.
Sir?
Yes.
Sir, why did we write 1 by 2 of the total energy on the capacitor?
Sorry, my mistake. This is 2C only. Q square by 2C.